Hello friends, I welcome you in lecture number 6 on estimation. In previous lecture we have discussed about confidence interval formula for large sample as well as small sample. So if we recall that the large sample confidence interval formula with 1 minus alpha into 100% confidence level is x bar plus or minus z alpha by 2 times population standard deviation divided by square root of n. So using this formula we can find out the interval which contains population mean with 1 minus alpha into 100% confidence. So here we are considering the example for the construction of a confidence interval for large sample. A random sample of size n equal to 100 is taken from a population mean with standard deviation sigma equal to 5.1. Given that the sample mean is x bar equal to 21.6, construct a 95% confidence interval for the population mean mu. So first we write down whatever is given. The level of confidence is 95%, so we can write that value of 1 minus alpha is 0.95. Therefore alpha will be equal to 0.05, because here we will require this value z suffix alpha by 2. Now if alpha is 0.05, alpha by 2 will be equal to 0.025. So in this formula first we require this z alpha by 2. So first we find out that value z alpha by 2. For that we have to use the standard normal tables. Now as we have discussed that if we consider this type of process of estimating a population mean mu, then we know that z equal to x bar minus mu over sigma over square root of n is a standard normal random variable, and the graph of standard normal random variable is bell shape curve, and here the confidence level is 0.95. so if we consider this 2 points, suppose this point is z alpha by 2, this point is minus z alpha by 2, and in the middle we have mean equal to 0. So this area is 0.95, and area in both the tails will be equal to alpha area, total area in both the tails is 0.05. Therefore area in right as well as left tail will be 0.025, and this is the standard normal curve, and we know that the area to the right side of z alpha by 2 is 0.025. therefore we can write that probability that z is bigger than z alpha by 2 is 0.025. therefore we can write that 1 minus probability that z is less than or equal to z alpha by 2 is 0.025. that means probability that capital Z is less than or equal to z alpha by 2 is 1 minus 0.025. therefore probability that z is less than or equal to z alpha by 2 is 0.975. so in the standard normal table we have to search for that value of z alpha by 2 for which the area under the normal curve is 0.975. so for that we use cumulative standard normal probability table, and these values in the table are this type of cumulative probabilities, and we are having the probability that z is less than or equal to z alpha by 2 is 0.975. So we search for 0.975 in the table. So for that we have to look carefully. I have to search for 0.975. So here I get 0.975, and you can see this corresponds to the value of Z in the row as 1.9, and the column corresponding to this 0.975 is 0.06. So here we have 1.9, here we have 0.06. That means we have to add 1.9 and 0.06. So the value of Z will be 1.96. So the value of Z for which we obtain 0.975 is equal to 1.96 from the standard normal probability table. So here we substitute Z alpha by 2 equal to 1.96, and here we can say that this is 1.96 and this value is minus 1.96, and we can write this as Z suffix 0.025 is equal to 1.96. So if you wish, you can remember this value. We are going to use this type of values frequently, and if you don't want to cram this, you can derive from the standard normal probability table within 1 or 2 minutes. It is not necessary to sketch this curve. This I have sketched just to understand the process. So Z suffix alpha by 2 is 1.96. So that we can write here Z suffix alpha by 2 is 1.96, and we are given that sample size is 100, population standard deviation is 5.1, and x bar is 21.6, and we have obtained Z alpha by 2 also, and sample size is large. So we have large sample confidence interval formula. So large sample and confidence level is 95%. So we can write that large sample confidence interval formula with 95%. So large sample 95% confidence interval formula is we have written that x bar minus Z alpha by 2 times sigma over square root of n. This is the lower limit for the confidence interval, and upper limit is x bar plus Z alpha by 2 sigma over square root of n, and we are having all these values. X bar, that is sample mean, is 21.6. We obtain Z alpha by 2 as 1.96. Sample size is 100, so we have square root of 100, and sigma is 5.1 if I am not wrong. Okay, so it is 5.1. So here we write 5.1 less than or equal to mean, that is population mean. X bar is 21.6. Okay, so this thing is similar to this except positive sign. So I copy from this 1.96 5.1 over square root of 100. So after calculating these two quantities, we obtain that confidence interval is 20.6 less than or equal to population mean mu less than or equal to 22.6. So the interval which contains population mean is 20.6 to 22.6 with 95% confidence. So we can say that we are 95% confidence that we are 95% confidence that the population mean mu lies in this interval 20.6 to 22.6. so this is our confidence interval with 95% confidence level. So it is easy to construct the confidence interval for the population mean. We just have to remember this formula: x bar plus or minus z alpha by 2 sigma over square root of n, and we must be able to decide the value of z alpha by 2 for given confidence level. Here confidence level is 95%, so alpha by 2 is 0.025. So in this way we can construct the confidence interval for large samples in which standard deviation is known to us. So this is all about this session. I hope you like it. Thank you very much.